Okay, this is chapter 1, section 8, part 2. We finished up with that example, and we're going to move on to page 4 of the notes. Solving a rational inequality. So, you know, we're looking heavy on this word right here, rational. That's like ratio, folks. These are fractions. I mean, the process is very similar, except how you get your boundary points. That's what's different. Everything else is the same. You gotta get your boundary points. You gotta get your test intervals. So we're gonna express the inequality so that one side is 0. That's the same too. That's like that general form. And the other side is, here's the big thing. You have to make sure that it is a single fraction or a single quotient, which is going to mean that we are going to have to get a common denominator for some of these problems. But for right now, I think the first one's pretty easy. You're going to find your boundary points because we still need those. By setting the numerator and the denominator equal to 0. You're going to locate the boundary points on a number line again. And you're going to identify the test intervals. We're going to use substitution again. To locate valid solution intervals. That's going to be our true versus our false statements. You're going to graph the solution set. And give the interval notation. Interval notation. All right, ready to do an example? Ready or not, here we come. We're going to solve and graph the solution set. This one here is a fraction. These are rationals, okay? Numerator is x minus 5. Denominator is x plus 2. Greater than 0. All right? You got some checks to do here. We need 0 on the right side or on one side. And we need a single quotient. So we could check that off. That is true. I have a single fraction. And I got 0 on the right side. Boundary points. Folks, you gotta set the numerator and the denominator equal to 0. X minus 5 equals 0. X plus 2 equals 0. So here, x is 5. 5 is a boundary point. And here, x is negative 2. Negative 2 is a boundary point. Now, what you also have to keep in mind is because now you have a denominator and you have variables in the denominator, we also have to say what x can't be. Okay, so keep in mind that sometimes these restrictions are going to cause issues for us when we have an equal to. This one's not gonna matter because, you know, we're not equal to anyway. So even if this would say bracket, this would say parenthesis. Okay, and so that's what I'm trying to make you think about for future problems. Okay, x can't be -2 because that's a restriction. All right, so what are my test intervals? I'm not quite sure why this pen isn't writing correctly. Test intervals. You know, you could write them here. I'm -2 and 5, so -2 is first on the number line. So negative infinity to -2, and then the middle, -2 to +5, and then the end, 5 to infinity. All right. It's greater than, so I got parentheses on everything. I'm considering my restriction that it can't be -2, and that's okay because it won't be because I have a parenthesis on -2 anyway. All right, pick a number that's on this interval. Well, you know, -1 is not on this interval. To the left of -2 is -3. So I'm going to test -5. Here, 0 is in between, so I'm going to test 0. And here, I'm probably going to pick a 10. All right, so now I'm going to set up my testing. All right. I have to go up into my original inequality, so I'm going to copy the original. It's x minus 5 over x plus 2. Greater than 0. All right. I'm going to go back. X minus 5. If x is -5, well, -5 minus 5 is -10. Over. -5 minus 2 is negative. Is it -2 or +2? Oh. Nope, it's +2. Sorry. Okay. Again. Substitute -5 here. -5 plus 2 is -3. Greater than 0. Well, we're going to determine that in a moment. All right, so if I put zeros in here for x, this is -5 over 2. Is that greater than 0? We're going to substitute a 10 in. 10 minus 5 is 5. 10 plus 2 is 12. Greater than 0. Now, you might think you have to figure out what this is, but you really don't. -10 over -3 is, this is a positive number. Is a positive number greater than 0? Yes, it is. This is a negative number greater than 0. No, it's not. This is a positive number greater than 0. Yes, it is. And so my solutions lie right here where it's true. So here and here. Now we're going to draw the number line. I guess I'll draw it over here. It's not very straight. And my solutions are going -2 to the left, parenthesis, shading, okay, and then at 5, shade to the right. And then my interval notation for the solution is going to be negative infinity. Oops, I don't know why that happened. Oop. Negative infinity to negative 2. Parentheses and union with. I like this tablet writer, but it's really messing up a little bit. In union with 5 to infinity. Okay, so not that bad. A little bit long, but not terrible. Different way of getting your boundary points because you have to get them from the numerator and the denominator. Now we're going to do an example of one where you have to actually get the single fraction. That's our next example. All right, so let me go back to purple, I guess. All right, solve and graph the solution set. So, my example is 2x divided by x plus 1 less than or equal to 1. Folks, I do not have a 0 over here. I need to get the 0 on one side, and I also need a single fraction or a single expression, rational expression. So I have to subtract the 1 over 2x over x plus 1 minus 1 less than or equal to 0. I now have to get a single expression over here. This is two things. This is two terms. So I need a common denominator, and that common denominator is x plus 1. So this 1 is going to be rewritten as x plus 1 over itself x plus 1, because this thing equals 1, right? This thing equals 1, that green 1. So this is the same, and this is minus 1. Okay, so keep that in mind, that that's minus 1. But I rewrote it this way so I can have a common denominator, less than or equal to 0. Now I'm going to move this, and you need to be careful because this is a quantity. And I'm going to change this and move the negative up here. You have to distribute the negative. If you don't distribute the negative, everything's going to be wrong. So now I have one expression with a denominator of x plus 1. And this is going to be 2x, subtract x, subtract 1. Less than or equal to 0. And now when I combine like terms, 2x minus 1x is 1x. So this is x minus 1 over x plus 1 less than or equal to 0. Now I can get my boundary points. Okay, you have to have a single expression to get your boundary points. So my boundary points are found by doing x minus 1 equals 0 and x plus 1 equals 0. You should also consider your denominator restriction. X cannot equal negative 1. This is important. And it is important for this problem because this says use a bracket because it's equal to. But on this boundary point, you can't use a bracket. So here x is 1, and here x is negative 1. Those are my boundary points. Now I'm going to set up my intervals. All right. So my first interval, look, -1 is to the left of +1. So I'm going to go negative infinity to -1. In between is -1 to +1. I'm not doing my parentheses or brackets yet because I don't want to think about 10 things at one time. My third interval is 1 to infinity. So okay, so I like to write down what the intervals are first, and then I like to figure out if I need parentheses or brackets. Then I don't make a mistake. Well, we know on infinity it can only be parentheses. And we know from the original inequality that it is equal to, so we need brackets. But we have this problem here. At the -1, I can't use a bracket. So it is parenthesis on -1, but on +1, it's bracket. Okay, and that's because this was a rational inequality. And this -1 was a restriction in the denominator. All right, now that I have my intervals, I'm going to choose values on those intervals. You know, to the left of -1 is -2, so I could choose a -2 to test. In between -1 and +1 is 0. I like when 0 is available. And from 1 to infinity, I guess I'm going to pick a 2. All right, so remember, this is what I'm testing. And you do have to test in the original. Let's sneak back up here. The original was 2x over x plus 1 less than or equal to 1. 2x over x plus 1. Less than or equal to 1. All right, so I'm going to substitute my -2 in. When I substitute my -2, this is 2 times -2 or -4 over -2 plus 1 is -1. Is that less than or equal to 1? Well, we don't know. I'm just going to set these up right now. The numerator is 0. 2 times 0 is 0. I don't care what the denominator is. That side is a 0. 0 less than or equal to 1. And then when I substitute a 2, this is a 4 over 3. 4 over 3. Is that less than or equal to 1? All right, now I'm going to check for my true false. This is +4. Is that less than 1? No. 0. Is that less than 1? It is. It's not equal to, but it's less than. 4/3. Now be careful. You might think because this is a fraction, you might think it's less than 1, but this is a fraction that can be turned into a mixed number. This is a number greater than 1. 4/3 is 1 1/3. Is 1 1/3 less than 1? No. And so I'm ready to give my solution because I see that the solution lies right here on this interval. That's where my true statement is. So I'm going to draw my number line so I can give a graph. What were my boundary points? Well, they're here, -1 and 1. -1 is to the left of 1. I'm shading in between, so I've got a parenthesis on -1 and a bracket on +1, and I'm shading between. And my interval for the solution is parenthesis at -1, going up to 1 and including the 1 on that side. So again, not too terribly difficult, just long. If you have any questions, please ask in class or post a comment on the discussion. Have a great day.